Hello again. This book is often cited as being the first true steampunk novel. It is Difference Engine, published in 1990. Difference Engine is set in an alternative universe, Britain in 1855, in the full flow of an information revolution. The point of divergence from our own world is sometime in the early 1820s, when a brilliant scientist perfects a huge mechanical computer. This initial invention, the difference engine of the title, is soon superseded by vastly more complex computers called analytical engines. These are powered by steam engines. The use of information technology at such a time causes upheavals in society, leading firstly to the imposition of martial law by Prime Minister Arthur Wellesley, Duke of Wellington, followed by a civil war and revolution. With the Industrial Revolution enhanced by an information revolution, British society is transformed into a meritocracy of intellectuals and scientists. This, in brief, is the plot of the novel. Different engines had appeared before in other science fiction novels of the proto-steampunk variety, before the publication of the Difference Engine, of course. In Harry Harrison's Transatlantic Tunnel Hurrah, published in 1972, Charles Babbage's Difference Engines also feature. Just as in the original machines planned by Babbage, the computers in this book consist of spinning metal shafts and cogwheels. They are entirely mechanical. However, unlike those in the Difference Engine, the driving shafts in Harry Harrison's novel are turned not by steam but by electricity. Here is a description of the thing in operation. He opened a door with a flourish to disclose serried ranks of slowly turning silver discs, all of them perforated with large numbers of small holes. Metal fingers riding on rods brushed the surfaces of the discs, bobbing and clicking when they encountered the openings. This is a calculating machine with brass camshafts which need to be oiled regularly. It is in fact a modified version of a Babbage difference engine. There's no reason to suppose that Bruce Sperling and William Gibson, who wrote the difference engine, copied the idea of working Babbage engines from Harry Harrison. It's more that both writers engage in the same looting of the past to provide the material for their imaginary worlds. There is something indescribably entertaining about the ideas explored in the difference engine. Perhaps the main attraction is the stupendously outlandish notion of computers which are driven by steam. It is so obviously the stuff of fantasy. Perhaps it will therefore come as something of a surprise to discover that such mechanical computers, with provision for a man to tend the steam engine which ran them, were actually being planned in the 1820s and came very close to being built. Just as with other seemingly bizarre aspects of steampunk novels, the steam computer is firmly rooted in historical reality. Charles Babbage was born in 1791 into a wealthy family. Even before he went to Cambridge University, young Charles had shown an inventive flair. He devised and constructed, for instance, a pair of shoes which enabled him to walk on water, essentially a pair of wooden balls attached to shoes like giant skis. These worked for a short while before Babbage toppled over and nearly drowned because his shoes made swimming to safety all but impossible. At Cambridge, Babbage made friends with John Herschel, who in later life became a famous astronomer, chemist and pioneer of photography. Charles Babbage's inclinations were more towards mathematics, and he went on to become both a member of the Royal Society and also Lucasian Professor of Mathematics at Cambridge, a post later held by Stephen Hawking. Charles Babbage had various ideas, some revolutionary, others frankly bizarre. It was to Herschel in the summer of 1821 that Charles Babbage made a famous comment which first suggested the notion of a steam-powered computer. Babbage had been working his way through some tables and was dismayed to discover many errors, so many in fact that he thought that the mistakes rendered the log tables all but worthless. He exclaimed to his friend in exasperation, "I wish to God these calculations had been executed by steam." Steam power was the very epitome of efficiency at that time, and it was hardly surprising that Babbage should have seen it as a remedy to human error, much as in our own time we looked at digital technology to solve some of our problems. One of his greatest plans was for a device which would carry out mathematical calculations. This grand idea, which Babbage fleshed out over the next couple of years, was for a gigantic mechanical calculating machine which would work out things such as logarithms and then print out the results automatically, thus removing all human error from the process of putting together log tables. Because of the possibility of vastly improved tables which would aid the British Navy in their navigation, the government was interested in the idea of infallible log tables, and in June 1823 a meeting was arranged between Babbage and the then Chancellor of the Exchequer, Frederick John Robinson. Unfortunately for both Charles Babbage and the British government, no minutes were kept of the meeting between the eccentric scientist and the man in charge of the country's finances. After it was over, the two men had very different ideas about what had been agreed. What was never disputed was that the Chancellor of the Exchequer had agreed to hand over £1,500 in connection with Babbage's marvellous mechanical computer. As far as the Chancellor was concerned, this was the total cost, and for that sum the government would receive a completed model of the new machine. Babbage, on the other hand, thought that he had made it clear that the £1,500 was merely a down payment, a preliminary amount which would enable him to begin work on the project. £1,500 was a substantial sum of money in 1823, at a time when an agricultural labourer might earn perhaps £20 a year. One can sympathise with the Chancellor of the Exchequer for thinking that such an amount might buy him a new kind of machine for aiding in the navigation of the Navy's ships. On his side, one can see why Charles Babbage believed that £1,500 would merely lay the groundwork for what he hoped to achieve. The engineering involved in the project required cogwheels to be made to very precise sizes, and it was essential that each should be perfect or the working of the entire machine would be compromised. New machine tools had to be built simply to make the components of the difference engine. The cost spiralled, and having invested already a large sum of money, the government was at first reluctant to abandon what appeared to be a very useful piece of work, a machine which would make all sorts of calculations without any possibility of error creeping in. Not only that, it would actually print out these calculations as well. Having sunk thousands of pounds in the construction of the difference engine, successive governments were reluctant to abandon the project, and little by little handed over ever larger amounts from the Treasury. In 1829, the then Prime Minister, the Duke of Wellington, went to see a model of what Babbage hoped the difference engine would look like if completed. Wellington was impressed and arranged for a further £3,000 to be given towards the project. 5 years later, with the difference engine still not completed, Babbage told Lord Melbourne, who was now Prime Minister, that he wished for more money towards an entirely new machine which he thought might be possible. This was the vastly more complicated analytical engine, which would be 8 foot tall and weigh as much as a railway locomotive. Not surprisingly, he was told that until his difference engine had been completed, there would be no money available for any new ideas. After 11 years, it was looking to many people as though Charles Babbage was never going to produce anything practical, no matter how much money he was given from the public purse. The curious point is that by this time the analytical engine which Babbage envisaged would have been far too large for the various cranks and cogs to be turned by hand. He drew up detailed plans for such a machine to be operated by its own steam engine. Steam-powered computers so very nearly came to pass. In 1842, Babbage, after having spent thousands of pounds provided by the Treasury, in addition to a huge amount of his own money, had still not produced a completed machine. This was the point at which the government decided enough was enough, and they pulled the plug on the difference engine by refusing to pay any more towards its development. The British government had by now given Charles Babbage an incredible £17,000 and in effect received nothing at all in return but promises of future wonders. Small sections of the difference engine had been built, but nothing that was of any practical use. In the novel The Difference Engine, of course, history turns out rather differently, and the difference engine of the title, really the analytical engine which Babbage envisaged, was an enormous success which revolutionised Victorian society and kick-started the information revolution well over a century before it took place in our own world. Had things worked out in just a slightly different way then, this could very easily have been the course of history in the real world.